Y'all, we might be seriously wrong about the universe, specifically about dark energy. Dark energy is a name that we give to the thing that's causing the expansion of the universe to accelerate, and it's most commonly treated as a cosmological constant. There's some constant intrinsic density of dark energy throughout the universe and throughout time. This is so fundamental, it's even the name of our best model of cosmology. It's called Lambda CDM, where CDM is cold dark matter and lambda is dark energy as a cosmological constant. But there are new results from the Dark Energy Spectroscopic Instrument that suggest that dark energy might not actually be constant. As a vast oversimplification of their methods, they look for patterns in the distribution of galaxies throughout the universe. The specific things they're looking at are called baryon acoustic oscillations, and as the universe expands, they get bigger. So by looking at the size of these oscillations as you look further out into the universe and thus further back in time, you can actually map out the history of how the universe has expanded. You can make plots like this that show the size of the universe compared to how big it is now throughout its entire history. They then combined their data with other observations of the universe like supernovae and the cosmic microwave background and fit their results to a bunch of different cosmological models. Our standard model with a constant dark energy would be found right here where these dashed lines intersect, but the models that actually fit their data better are represented by these contours. This suggests that dark energy isn't constant. It has changed over the history of the universe. And this is statistically significant. They're ruling out a constant dark energy at levels from 2.8 to 4.2 sigma depending on what datasets they combine. Although typically 5 sigma is the gold standard for a big discovery in physics, so we're not quite there yet. And as they point out in their paper, there could be some sort of systematic error in their analysis or in the way samples are selected, or again, it could just be a statistical fluke, but that's all pretty unlikely. And if this gets validated by future observations, that's a big shift. Remember, the idea of a constant amount of dark energy is literally in the name for our standard model of cosmology. But this is just how science works. We get new data, and if it doesn't match our best models, then we change those models and evolve. And this wouldn't be something where we have to throw everything out the window. Any changes in dark energy would have been relatively recent, so things like the age of the universe, dark matter, structural formation, all of that would be relatively unchanged. But it does change our future. Constant dark energy predicts a continued accelerated expansion. But if that acceleration is slowing down, then maybe one day the expansion will stop and the universe could crunch back in on itself. But this is pretty exciting stuff. We'll just have to wait and see what future observations show us.